So our next speaker is Galache from Engineering and other entities, NASA-related entities. And so he's going to talk about the outcome from the Asteroid Science and Intersection with Supply and Engineering Conference last year. Jill.
Thanks, Mara. And Mara's name is there because she was the mastermind behind this workshop. So thank you very much for all your work and your ideas, Mara. And this is what I call a loose acronym.
It was very loose.
Yeah, that's what ASIME stands for. This all came about because Amara was embedded in asteroid mining, and I've had a long-standing interest. And what we were seeing is that we had the asteroid mining companies and the scientists, and they were sort of in separate camps mostly. There wasn't much engagement. So the plan was to take the asteroid miners, get some scientists, lock them up in Luxembourg, and then great things were going to happen. If anybody appreciates puns. So the miners would drill the scientists. We asked for questions. What is it that you need to know scientifically about asteroids that is going to help you achieve your goals of mining an asteroid? And we did receive a large number of questions. And as it may happened, these are all the people that attended. So we had the 3 asteroid mining companies, a few dozen scientists, some engineers, and some people like Matthias, and policy people, lawyers, and business and finance people, which was great. And we identified, through the white paper, subsequent white paper, 6 knowledge gaps that were, I guess, the major holes in the asteroid mining plan. And I'll go through them. So the first one was mapping asteroid spectra to meteorite spectra. And there's been ongoing work for, I guess, decades on this. And yes, I know that's Vesta and that's an iron meteorite, okay, but artistic license. So we've been able to map some S-type asteroids to chondrites, but really there's no one-to-one clear mapping. So we need to fix that so that when we take spectra of asteroids from Earth, we can really know what they're made out of. The next one is related to this. So the spectral characterization of asteroids is something that's done for scientific interest, but not necessarily for a mining interest. And there are no dedicated telescopes or facilities to perform this. All these telescopes here discover and follow up astrometrically the asteroids, but none of them perform spectroscopy, and there is no dedicated facility to that. So if we want to characterize the near-Earth asteroids as they're being discovered, which is when they're brightest, then we need dedicated telescopes for that. Another knowledge gap is understanding regolith dynamics in microgravity within a space mining environment. So here's an image of Eros, and it's very interesting. Downhill is that way, and you can tell that all the rocky regolith is here, and all the dusty regolith is downhill. And for scale, let me see, that boulder there is about 5 meters. So what we think happens here is that when there are impacts, did I say Eros? This is Itokawa, sorry. When there are impacts on the asteroid, the vibrations that are induced make the fine regolith fall downhill. So those are one of the things that we understand. What's going to happen when a probe lands on it? We kind of have an idea based on 67P, but how is that going to affect mining equipment when it disturbs the regolith? And this is a photo of Jack Schmidt, I think I got that name right, the only geologist who's been on the moon. And you can see that his trousers are covered in lunar dust, and that was a problem they had. So we need to know how that's going to affect mining equipment, for example. Knowledge gap 4, identify the good asteroids. So these are actually just the potentially hazardous asteroids, but we now know about 17,000 near-Earth asteroids. 2,000 new ones are discovered each year. Which ones should we be mining? So we want them to have a low delta V, so it's easy to get to and come back from them. Ideally low synodic period. And initially we want them to be dark because we want carbonaceous asteroids that are water rich. But low delta V doesn't necessarily correlate with low synodic period. So ideally, we would have a large catalog of asteroids with low delta V, such that at any given point in time, you have maybe an asteroid per month that you're able to launch to that is an asteroid that's valuable to bring back. So whatever your launch window is, there will always be an asteroid for you to go and mine. And gap number 5. So this is a little bit of a very early distribution of the asteroid types in the main belt and a little bit beyond. But we know the main belt feeds near-Earth asteroid space. So if we can figure out where an asteroid, a near-Earth asteroid, came from in the asteroid belt, could that tell us what it was made out of? Not in absolute terms, but if it came from the inner asteroid belt, then we know it's most likely not going to be a C-type because there's a low probability. If it came from the outer belt, then there's a higher probability that it will be a C-type. So for asteroid mining companies, being able to quantify risk in this way, by being able to say this near-Earth asteroid that we don't have spectroscopically classified, but we know where it came from in the asteroid belt, has a 30% chance of being water-rich, that is better than we have no idea. And the final gap is to improve regolith simulants. And I believe this is one of Phil's. Yes, it is yours. Okay. Used without permission. And so here we have a schematic of an asteroid and how we think regolith is probably distributed. But although we can guess or infer what the surface properties are from thermal observations of asteroids, we really don't know beyond a few centimeters what's going on. And that's going to be really important because the asteroid mining equipment is going to be likely digging and is not just going to be scraping the surface. So in order for Phil to be able to do his job, and he's going to be talking about this, we need to understand much better what the properties are of asteroid regolith. And some of the missions that are now going to collect samples are going to be important in that way. But we also need to understand what goes on below the surface. And I actually did it in my time. So I want to thank, and Amara wants to thank also, the 32, I believe, people who helped us with the white paper. Some were present at ASIME, some very kindly read the document that was online for everyone to see and made important comments. So thank you very much for these co-authors, and I suggest that you go and read the white paper. It's available on the archive, and I think if you just look for Graps as the main author, it'll be easy to find. So thank you very much. That's why I didn't use that plot.
Yeah. And in fact, with our research, we like to go to the easiest targets, which are both C-types, and they are nearest asteroids. So
yeah,
we have to be careful about the link between the two. And the other thing was you didn't mention the rotation period, but the fast spinner could be also a problem for mining.
Yes. So if you read the white paper, there are these are like the biggest knowledge gaps. Oh, yes.
Patrick Michel was just commenting on the sizes.
Yeah, so Patrick Michel was saying that the plot I had used, which I intentionally used this one just because of its simplicity, this is mostly for large asteroids in the asteroid belt. There are new studies by Francesca De Maio looking at much smaller asteroid sizes. And when you look at this actually distributed by mass, not by number of asteroid, because this is numbers, then it's not as pretty. There is a lot more mixing going on. So being able to map, I don't know to what extent we're going to be able to actually reduce the uncertainty of asteroid types.
Any other questions?
And Patrick, he also mentioned spin. That And yes, that is an issue. And that goes into really the follow-up telescopes. There are no dedicated follow-up telescopes to take light curves because it's so time intensive.
So the idea is to mine for water, or what exactly are you doing?
Well, I believe that eventually we're going to mine for everything, and that we'll use everything that can be got from an asteroid. But the first commodity we believe is going to be water. So it's not water ices. We're going to take hydrated minerals and take the water out of those. And the idea is for it to be sold in low Earth orbit. You can use water as is, drinking if there are people to drink it, but you can also produce fuel from it and oxygen for breathing. Radiation shielding. Very useful substance, water. Yeah.
Okay, we need to stop and go on.
Okay, thank you.